So, a very good evening. My name is Samiksha Chauhan, and my topic is glycosidase enzyme. This is a pretty cool enzyme. It is also known as glycosyl hydrolysis, glycoside hydrolysis, and I've got a lot of things covered in this poster. And if we don't start with the basic, we might not get the track where I'm ending to. So, the definition, if we look into, is that an enzyme that catalyzes the hydrolysis of a bond joining a sugar of a glycoside to an alcohol or another sugar unit. So this basic definition, I think, might have helped you to understand what is the basic role of the glycosidase. So now talking about the availability, it is basically found in fungal cultures, in high organisms like mollusk and plant seeds. So its availability is high, and on the other hand, it is also stable, and therefore we prefer glycosidase over the glycosyl transferase. Moving ahead, it has a very unique property called stereoselectivity, and henceforth, it has in practical application of it, which is in the separation of a mixture chemically prepared by alpha and beta glycosides. Moving ahead with the classification, so it is endoglycosidase and exoglycosidase. We have actually heard this terminology a number of times now. So this endoglycosidase talks about the cleavage of internal glycosidic bonds, and wherein glycosidase, exoglycosidase, that release a single monosaccharide from the non-reducing terminus of an oligosaccharide. This is a very pretty start where actually we had a knowledge about it. And moving ahead to the structure of the glycosidase. So yeah, I have got this from the Brenta. Uh, Wherein this enzyme is seen in E. coli given, which is in model microorganisms in Homo sapien, and then I can see, if my pointer is helping you in the Homo sapiens as well. Okay, the location as well. Most of eukaryotes have this glycosidase in endoplasmic reticulums, Golgi apparatus, and lysosomes. Moving ahead with the reaction. Now I have got just one reaction from the Brenda because it stated a lot of organisms in which glycosidase, as in substrate, helps in producing amazing products and help in the uh, uh, life cycle. Moving ahead to the reaction, the substrate is 2,6-diamino 4 hydroxy 5 for mamidopyrimidine, which gives a product called 2,6-diamino 4 hydroxy 5 for amidopyrimidine plus cytochrome DNA. With the addition of this thing, water. Then this we can see in Homo sapiens only. Yeah. So if I move ahead with the other topics of it, it is basically talking about the mechanisms of glycosidase, where we are talking about the inverting mechanism, which is its first mechanisms that generally involves nucleophilic attack of water and the anoramic centers, with the acid catalyzed departure of leaving group. Okay, as the leaving group. Now, this reaction occurs via a single displacement mechanism, wherein one carboxylic acid acts as a general base and other as a general acid. The second is the retaining mechanism, which occurs via a double displacement mechanism, wherein one carboxylic acid acts as a general acid base and other as a nucleophile. The third mechanism, which is very important, retaining in stereochemistry, which involves the assistance from the neighboring 2-acetamide group of substrate. So this reaction is often named as the substrate assisted mechanism. This is a very simple mechanism. As we see other enzymes, they have very complex mechanism. Here it's very simple, inverted mechanism, single displacement mechanisms, and then lastly is retaining the stereochemistry via the substrate assisted mechanism with the help of substrate. Now we have the application of it. The use of glycosidase in industries, microbial glycosidase for wine, then as engineers biosynthetic instrument, potential role of glycosidase inhibitors in applications of oligosaccharides. Now we also have some uses of it, which are glycosidase stereoselectivity practical applications, which we talked about, separations of mixture. Then they are also used in diagnostic drugs, discovery and development, oncology, immunology, which are running field nowadays. And it has a lot of future scope where we can use this glycosidase enzyme. Okay. Um, as you can see, I've missed this diagram. I'm really sorry for this. But yeah, this is a very general mechanism. I would like to zoom it a little, where, we are basically saying the applications of the glycosidase. I have found it a little simple for me to understand, and henceforth I could make you understand with the diagram. So this glycosidase normally catalyze the selective hydrolysis of glycosidic bond, but it has been shown that they can also be used for the synthesis. With non-activated free acceptor sugars, the reaction conditions are generally performed in low water activity system, such as biobasic aqueous organic media, or with high concentration and excess of donor alcohol. So these are efficient donors. Okay, substrates for glycosidase are basically maybe phenolic glycosides, such as para-nitrophinin glycosides. Yeah. So this advantage of using such reverse glycosidations are in their broad substrate range. Glycosidase tend to high selectivity for the donor substrate, but have more relaxed specificity for acceptor, and hence can be used to generate a broad selections of glycosides. Glycosidase are also readily available for a wide range of donors and are often fairly stable enzymes, which are easy to use in the synthesis direction, stereoselectivity, but sometimes it lead to mixtures of the regioisomers, a little drawback of it, but otherwise it is very helpful in as we discussed over here. Then lastly, we got the industries which produce glycosidase, and it has a very heavy competition. I've listed few because I've got this much space. So here we have the market of Agilent Technologies, New England Biolabs, Thermo Fisher Scientific, Takara Bio, Water Corporations, and Genotechnology, including USA. So nearby, it's not the whole help which I could provide you with this poster, but yeah, I have tried to cover a lot of things in here: history, structures, reactions, the application, uses, the mechanism, and a very general mechanism where I could make you understand where glycosidase is very prominently used. It has an application in industries as well. That is another a little longer explanation to it, which I would like to give, but for that I have to again show some diagrams and a further explanation to it. So yeah, I think hereby I have made you understand. Thank you so much.